All right, let's look at this question under method of mixtures. A piece of copper of mass 0.1 kilogram is heated to 100 degrees centigrade and then transferred to a well-lagged copper can of mass 0.05 kg containing 0.2 kilograms of water at 10 degrees centigrade. Calculate the final steady temperature of the mixture. And we're given some values here. Specific heat capacity of water is this, 4.2 times 10 to the power of 3 joule per kilogram per Kelvin. The specific heat capacity of copper is also given as 4.0 times 10 to the power of 2 joule per kilogram per Kelvin. So we are told to calculate the final steady temperature of the mixture. So it's a question under method of mixtures. Method of mixtures is basically saying that the quantity of heat lost by a hot body, okay, is the quantity of heat that will be gained by the colder or cooler body. Okay, so basically I'm looking at a piece of copper that's been heated that's to 100 degrees centigrade. So this is the hot body, the copper mass, right? And then it is transferred into a well-lagged copper can. So basically the copper can and water. So there's water in the copper can. So the heat lost by the mass of copper, the heated copper that is at 100 degrees centigrade, will be the quantity of heat gained by the copper. Right, so the quantity of heat lost by the copper can, quantity of heat lost by copper can, all right, quantity of heat lost by copper can will be quantity of heat gained. We say heat lost, okay, be quantity of heat gained by colder, the colder combination of the copper can and water. So let's get the quantity of heat loss. Okay, remember that Q is equals to mc delta theta. All right, where delta theta is a change in temperature. So let's get for our can, all right, copper. This is the mass of copper, kilogram. All right. So let's look at this. So we have, this is the quantity of heat by the quantity of heat lost by the hot body. That's the copper mass that is at 100 degrees centigrade. And this is the quantity of heat gained by the can into which is transferred into a well-lagged can and the water inside the can. So this is the quantity of heat for the can. All of this is for the can. All right, for the can. All right, and then this is for the water. Now take note, this T, they all, after a while, after they mixing them together, they all arrive at its final steady temperature. So T here, T here, and T here is the final steady temperature of the entire system of copper, piece of copper, the can, and the water. So we need to find that final steady temperature, T. So we have quantity of heat loss. All right, so let's get the quantity of heat loss. So the quantity of heat lost by the hot copper is basically the mass times its specific heat capacity of copper times the difference in that temperature, okay? Is equals to this 4000 minus 40T. By the time you put 0.1 times 4, this is specific heat capacity of that. So putting in those values, so you get this for the quantity of heat lost. And then the quantity of heat gained by the colder body, that's the copper can and the water itself. Put in the values. Remember, this is the formula mc delta theta, where delta theta is changing temperature. They all have the same T. We are looking for T, all right? So slot in the values, and at the end, you get that temperature is equal to 14 degrees centigrade, all right?